Okay, thanks to Ikarov for this next couple of videos. He's asked specifically for paper 2, 1, 2 and 1C, 1 to 4. And so I'll just do 1, 1 as just to help us do 1, 2. Alright, so just getting into it now. So this is, for this one here, this is just standard level. It doesn't go into the hybridization, so I'll just make this one just separate video for the standards, and so they don't get the hybridization bit. If you look at your periodic table, which you'll get in your data booklet, you'll have here that phosphorus has 5 valence electrons, and so you always draw out your structure with 5 valence electrons, and then you draw your hydrogen with its 1 valence electron. And what you'll do is you first start with drawing 1 bond to each, and then you count up. Hydrogen has 2, 2 and 2, so it has full valence shells. Phosphorus has 2, 4, 6 and 8, so that's the correct structure. And so to do the Lewis structure properly, so that's just your groundwork that you always need to do. You'll just do the dots here, and I'll do X's for the hydrogen. Make sure the dots are not lines, just in case the marker thinks that's a double bond. And then you just do the circles overlapping, and that's your electron dot structure. Okay, so that's it for the standard levels. For the high levels, I'll continue on, because when you're doing a hybridization down here, what the key is can you draw it in another way? And so for this one here, you could have drawn the hydrogens like this, or you could have drawn the hydrogens like this, and the last way is you could have drawn the hydrogens some other way, like this. Alright, so there's different ways for you to orientate it, and when there's different ways for you to orientate it, that's telling you that hybridization is going on. So you can kind of guess the hybridization from that, because it's very similar to methane, or it's very similar to carbon, and carbon has 4 bonds, so it's famously sp3, and so sp3 means there's 1 here and there's 3 here, so you've got 4, and that's what you've got. You've got this shape, this tetrahedral shape, and you can only get that tetrahedral shape if you have 4 equal bonds. Alright, and it's the same with ammonia, which is coming up in the question. So the hybridization is sp3, but the student asked me, or the teacher, I don't know who it is, Ikarov of most likely a student, has asked me why it's not sp2. If you have sp2, you don't have that hydrogen, these bonds being able to be shared and this being able to swap around evenly, because there's this weird, this one's not taking part in it, in the symmetry of it. So it's like with graphite, it's like when there's that symmetry, and the electrons can just hover around. This is the same sort of thing. There's a symmetry going on, and you're not quite sure what's going on and which shape it is, so that they could have been hovering around. I'm not actually sure what's going on that sort of level. I'm not sure if anyone can know that at the moment. Maybe they can. Maybe they've done a PhD on it or something. Just to take that a little bit further, if you do the electron shells and you draw it out, this is how it changed. So it's originally 3s2 3p3, and it's gone from 2 electrons. Just draw them like this. Sorry, it's the wrong, not nice. I've already drawn it now, so I'm leaving it as these funny arrows. It goes from this, so sp 3s2 3p3, and then once it gets hybridized, they all become even down here, and so now there becomes 4 of them, and that's the 3p3. So there's 4 3p3s now, and the difference is one of those has a full electron, has a lone electron pair. Okay, so that's what it looks like fully written. I don't think they could ask you anything more than that. And it's only worth 1 mark, so they're only asking you to state it. Okay, and so hopefully that was helpful. That'll help you work out all the other different hybridization questions that you could possibly get.